all are doing good. So let's start solving today's problem. So today's problem is about Geek and its game of coins. Now let's see how to solve this problem. So in the problem, it is given that Geek and his friends are playing a coin game. Now in each move, a player can pick up X coin or Y coin or a single coin in each move. So the player who picks up the last coin, remember the player who picks up the last coin is declared as the winner. So if Geek picks up the last coin, then he is declared as the winner. In that case, return a 1. If his friend picks up a last coin, then his friend is declared as a winner, and in that case, return a 0. So in the output, you can see that here I am getting an output of 1. That means this time Geek is winning. Also, I'm given with an additional information here. That is, Geek always starts the game. So Geek is the one who will make the first move, who will always make the first move. So let's proceed forward with these information. So my X was 3, my Y is 4, and also I am given with a condition that I can move forward with a single coin also. So let's see what happens when my N is equals to 0. When my N is equals to 0, that means I have a 0 coin. That means I can't pick up any coins because my N equals to 0 here. If I'm here given that my Geek always starts the game. So here, if Geek starts the game, that means he is going to lose the game. Isn't it? Because my N is 0 and I can't pick up any of the coins from here. Okay. Now, what happens if my N is equals to 1? If my, okay, here my Geek was losing. So what happens when N is equals to 1? When N is equals to 1, will it be feasible to pick up X equals to 3 coins? No, my N is 1. Okay, can I pick up 4 coins? No, my N is 1. So, can I pick up 1 coin? Yes, I can because my N is 1. So, if I pick up 1, will it lead to the winning of Geek? Yes, it will. So, here I will pick up N equals to 1. So, my Geek starts the game with 1 coin. And this leads to winning of the game because my Geek moves forward with 1 coin and here my N value is also 1. So, that means 1 minus 1, which is 0. I'm left up with no coins. So in this case, my Geek wins. Okay. Now what? Now let's see what will happen if my N is equals to 3. If my N is equals to 3, will I pick up this X equals to 3 coins? No, I won't because 3 is greater than 2. I won't pick up this coin. Will I pick this coin? Y equals to 4? No, because Y equals to 4. 4 is greater than 2. I won't pick up this coin. So it is feasible to pick up 1 coin. So my Geek will always start the game. So Geek starts the game with 1 coin. Now 2 minus 1. What is the remainder? It is 1. I'm left up with 1 coin now. So 1 coin. So this 1 coin is picked up by his friend. So his friend picks up the last coin. So whoever picks up the last coin is declared as the winner. So this time his friend wins because he picks up the last coin. So his friend is the winner this time. Okay, now let's see what happens when N equals to 3. When N equals to 3, my Geek will always start the game. So can I take this 3? Can I take this 3? X equals to 3 coins because my N is equals to 3. So yes, I can take 3 coins, which will actually help me to win the game. So if Geek takes 3 coins here, then this is the last move. His friend loses the game, and in this case, Geek wins the game. So here, Geek wins the game. Now what next? Let's see with N equals to 4. What happens with N equals to 4 now? Geek always starts the game. So is 3 less than or equals to 4? Yes, it is less than 4. But if I take 3, if Geek takes 3 at first, then obviously his friend will pick up 1 coin because I'm given with 3 options only, that is 3, 4 and 1. So if Geek picks up the 3 at first, his friend will pick up the 1 coin. That means my friend will win. In that case, Geek loses the game. So this is not going to happen. What I will do to avoid this, I will pick up Y equals to 4. I will pick up Y equals to 4. So this will lead to winning of the game for Geek. So here, Geek wins the game. Now what happens for N equals to 5? For N equals to 5, my Geek will win. My Geek will start the game with 3 coins at first. So my Geek will start the game with 3 coins. So his friend will move forward with 1 coin only because he is only having a single option, that is 1, as 3 is greater than 5 minus 3 is 2. 3 is greater than 2 and 4 is also greater than 2. 1 is only less than 2. So in that case, if my friend will move forward with 1 coin. Now, how many coins are left with? 3 plus 1, 4. And my total coins are 5. So 5 minus 4 gives me 1. So I am left up with 1 coin. So what I will do? I will, so my geek will pick up this 1 coin. My geek will pick up this 1 coin, which will lead to the winning of game for geek. So this time, my geek wins the game. So here my n was 5, my geek wins the game. How? My geek picked up 3 first, then his friend picked up 1 coin, then the geek picked up 1 coin, which ultimately led to the winning of game for geek. So here in the output also, you can see that I'm getting the correct answer. So this was all about it. Now let's observe something. From here, I can say that for n minus x, what is n minus x here? 5 minus 3 equals to 2. I picked up 3 at first. So 5 minus 3 is equals to 2 for n equals to 5. So for n minus x, that is when n is equals to 2. What is the value at n is equals to 2? Here, when n equals to 2, I can see that my geek was losing the game and his friend was winning the game. But here, when n is equals to 5, my geek is winning the game. So from here, I can conclude that for n minus x, my geek will lose the game, and for n, my geek will win the game. From this example, I can conclude this. Similarly, from this example, where my n was 4, my geek picked up 4 coins. So I am left up with 4 minus 4 equals to 0. So where is n equals to 0? N equals to 0 is here. So here you can see when my n was 0, my geek was losing. But when my n was 4, my geek was winning this time. So I can say here, from here, that for n minus y, my y was only 4 here. I'm subtracting here with n. So for n minus y, my geek is losing the game. And for n, my geek is winning the game. So from here, I can say that for n minus y, my geek is losing the game. And for n, my geek is winning the game. Similarly, I can say that for n minus 1, my geek is losing the game. And for n, my geek is winning the game. Okay, so that was all about this. With all these observations that I have made here, I will use these observations to implement the code. Now let's implement the code. So what I will do, I will simply take a DP. I will initialize to 0 at first. My DP at 0 will be 0 and my DP at 1, index 1 will be 1. Why I'm doing this? Because from here you can see that whenever my n is equals to 0, my geek is losing the game, and whenever my geek is losing the game, that means his friend is winning the game. In that case, you have to return a 0. So that's why I'm doing here dp 0 equals to 0, and whenever my n is equals to 1, my geek is winning the game. So from here I can conclude that dp at index 1 will be 1. Why? Because geek is winning the game. Now moving forward, for int I equals to 2, I less than equals to n, I will check for few conditions here. What I was checking? I was checking whether my n value is greater than or equals to these values or not, whether my n value was greater than x, y or 1 or not. In accordingly, I was assigning a coin to the geek. Here, my n was 1, so I was picking up a coin 1. Here, my n was 2, which is greater than 1. So that's why I was picking up 1 coin here. Here, my n was 3. So that's why I was picking up x here. So similarly, I will do the same thing. I will check if my I is greater than or equals to 1, and if my dp I minus 1 equals to 0. If this condition satisfy, that means in that index, my geek is winning. Now, what does this condition signifies? This condition checks if earlier, if at I minus 1 index, his friend, that is geek's friend, is equals to 0. That means he is winning the game. He has already played a game. That means this is his chance. That's why this index has been assigned a value 1, which means a true value. That means this time geek will win. Similarly, if this condition does not apply, What condition next? I will check for if my I is greater than equals to x or not, and my dp I minus x equals to 0 or not. If it is so, I will simply assign 1 if my I is greater than equals to y and my dp I minus y is equals to 0. That means my geek is winning the game. So if all these condition applies, in that case, my geek will win the game. If does not, in that case, who will win? His friend will win. So the last coin is if the last coin is 1, that means my geek is winning the game. In that case, I will return a 1, else I will return a 0. Let's compile and run. Okay, so the compilation has been completed. Now let's submit. Okay, so we have earned 1 geek bit for solving today's problem. So let's end the video here. Do subscribe the channel to get similar content, as gaining a subscriber and a like in my videos does motivates me a lot to be consistent and create more such content. So do subscribe, like and share it with your friends. If you have any doubt, you can ask me in the comment section. Thanks a lot for watching. See you guys again tomorrow.